I want to discuss negative powers with you because we've talked about rational powers and we've talked about integer powers. So now what happens when you have a negative? So what we want to do is we're going to try to fill in this table, and I would encourage you to take some time to do it before you watch me do it. But we're going to try to fill in this table using our calculator, okay? And then we're going to try to figure out what the pattern might be to evaluate negative exponents without a calculator so that we can kind of see what's the effect of our negatives. So I would encourage you to pause the video and try this on your own first. So what we want to look at is, first of all, what's 2 to the 5th? We know that that's 32. 2 to the 4th is 16. 2 cubed is 8. 2 squared is 4. 2 to the 1 is 2. And 2 to the 0 is 1. All right, 2 to the minus 1 is 0.5 if you do it on your calculator. 2 to the minus 2 is 0.25. Then it's 0.125. And then it's 0.0625. Okay? Now the question is, what is that as a fraction? All right, now these ones, it's just 32 over 1, 16 over 1, 8 over 1, right? They're all just over 1. Those ones are easy. But what you want to notice is that 0.5 is 1 over 2. 0.25 is 1 over 4. So hopefully you can see that, in fact, this flipped over is that, right? This flipped over is that. And so we can imagine then that this flipped over is going to be that, which means it's going to be 1/8. And if you take your calculator and divide 1 divided by 8, you will see that it is indeed that, and this becomes 1 over 16. Okay, so what we're noticing, hopefully, is essentially what a negative did, what a negative power did, is it kept the value the same, the 16 or the 8 or the 4 or the 2, but it just flipped it. So instead of it being in the numerator, it became in the denominator. And if you do that with 3, it's the same sort of thing. 3 to the 5th is 243. 3 to the 4th is 81. 27 is 3 cubed. 9, and then 3, and then 1. This is 0.3 repeating. All right, this is 0.1 repeating. If you take your calculator, just to show you where I'm getting these from, if you didn't do it on your calculator on your own, let me open my calculator. There we go. Oh, now it's going to open 3 of them. So if we take 3 and then we raise that to the, let's see, minus 3. So we go 3 negative. Then we'll get 0.037037. So we get this repeating. Okay. And then if we do 3 to the minus 4, we'll get another repeating decimal. It's 0.123456789, and then 0.123456789. So it's 0.0123456789 repeating. I messed that up. But you get the idea. So if we write these as fractions, we get 1 over 243. Sorry, not 1 over 243. 243 over 1. We're just really, these all are just over 1. We normally just don't write them. But again, if you look at your calculator, if you take 1 over 3, you know, well, you probably know that one. 0.3 repeating is 1 over 3. If you take 1 and divide it by 9, okay, you're going to get that 0.1 repeating. So 0.1 repeating as a decimal is 1 over 9. And then we can check, is 1 over 27 equal to that 0.037 repeating? And it is. So this becomes 1 over 27. And then again, we can type in 1 over 81 and see if it's that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, there's no 8. 0, 1, 2, 3, 4, 5, 6, 7, 9. 0, 1, 2, 3, 4, 5, 6, 7, 9. 0, 1. So it is that. It's 1 over 81. So what that should allow us to do then is to come up with a sort of conclusion, okay, that a negative power 2 to the negative power, and let's say it's just negative n, I'm just going to say it's some number, should be 1 over 2 to the n, all right? Or with 3, right? 3 to the negative n, we would say is 1 over 3 to the n. The problem with that is simply that we've only checked 2 and 3, right? So we know that it works for 2 and 3 maybe, but what about some other numbers? So let's just try it. So we're just going to take a couple other numbers and see if it works the same way. So 5 to the minus 2. I'm gonna guess that that's 1 over 5 squared, which is 1 over 25. That's my guess, my educated guess, all right? I'm going to test it and see if it is. So 5 raised to the minus 2 gives me 0.04, and if I divide 1 by 25, I get the same thing. So that is correct. Okay, let's pick another one. Let's say I take 7 to the minus 3. So I would say that's 1 over 7 cubed. That's what I'm going to test. And so if I do that, 7 cubed, I don't know what that is right off the top of my head. Maybe you do. If you do, good for you. So let's test that. 1 over 343 is that. So then let's see if we get that when we divide, or then when we do 7 to the minus 3. So 7 to the minus 3, see if we get the same number. And we do. It's exactly the same number. So we know then that this is probably going to work for all of them. And in fact, it does. All right. So we can say if you have a negative exponent or a negative power, all you're going to do is flip the base. You're going to change the base from whatever it is to 1 over that. And then you're going to make the positive power, or the power positive, if you want to say it that way. So if it says what's 3 to the minus 2, what we do is we make that 1/3 squared, or 1 over 3 squared, because 1 squared, technically this is 1 squared, but that's just 1, right? So we get 1/9. Okay, here, this minus 3/4 gets flipped, so it becomes minus 4/3. And then cubed. Please don't make a mistake that a lot of people do and assume that this negative somehow relates to this negative. They don't have anything to do with one another, all right? It's not like two negatives make a positive. So people get that confused a lot of the time, and it's not something that we want to do. So if the power's in the, the negative's in the power, it has nothing to do with a negative that's out front here, okay? So we just leave the negative, and then we cube 4 and get 64, and we cube 3 and get 27, and because it's a negative cubed, it stays negative, okay? So that's my answer. And this is 1/9, and then 0.3 to the minus 4. You can do that on your calculator. You can also write it as 3 to the 10, right? That's what 0.3 is, the minus 4. And then you can flip it and make it 10 over 3 to the 4th power. And then you have 10 to the 4th over 3 to the 4th. 10 to the 4th is 10 with, or 1, I guess, with 4 zeros. And then 3 to the 4th is 81. So it's this. Okay, now if you use technology, all right, in terms of just taking a calculator out and doing it, you will get a decimal. So if I take, for example, this 0.3, let me just move this out of the way so you can see. If I take 0.3 and I raise that to the minus 4, it's going to give me this, 123.45679. If I take 10,000 and divide it by 81, I get the same thing. Okay, so they're the exact same thing. Now down here it says to evaluate these powers without using technology. So what we have to do is we have to first of all look at, there's a negative here. So I'm going to flip the base. I'm going to write it as 1 over 8. And then to the 2/3. Then you have to remember your rational powers. Okay, this becomes the cube root then of 1/8 squared. Now the cube root of 8 and the cube root of 1, they're both nice. The cube root of 1 is 1. Cube root of 8 is 2. So I get 1/2 squared. And then 1 squared is 1, and 2 squared It's on the bottom, so I end up with the answer of 1/4. All right, so I'm applying two different rules, the rational power and then the negative power, or I guess the negative power first. So then if I take this one, again, I have this negative power, so I'm going to flip the base. So I'm going to make it 16/9, and then change the power to a positive, so to 3/2. I'm going to take the square root then of 16/9, because that's what that 1/2 means, cubed. The square root of 16 is 4, the square root of 9 is 3, and then I'm cubing that. So 4 cubed over 3 cubed. 4 cubed is 64, and 3 cubed is 27. So that's my answer. Okay? We're just going to leave that there. You can try those questions out of your textbook.